Welcome to session 5 of Unit 2, and in this session we'll be looking at heat of formation. By the end of this session, you should be able to define the term heat of formation of a substance and calculate the heat of formation for a given reaction. Heat of formation is defined as the enthalpy change, and it is denoted with the symbol change in H to the power 0 or whatever you want to call it, then subscript F. So basically, it is defined as the enthalpy change for the formation of 1 mole of a substance in its standard state from its constituent element in their standard state. So what are the standard states we are actually talking about? So 1. For a gas, the standard state is a pressure of exactly 1 atm. For a solid present in an ideal solution, the concentration is exactly supposed to be 1 molar at a pressure of what? 1 atm. Also, for a pure substance or a solvent in a condensed state, that is a liquid or a solid, the standard state is a pure solid or solid under a pressure of 1 atm. For an element, the form in which the element is most stable under 1 atm of pressure. One exception is phosphorus, for which the most stable form at 1 atm is black phosphorus, but white phosphorus is chosen as the standard reference state for zero enthalpy of formation. And also, by convention, the stable form of any element is always 0. The stable form of any element is 0. The standard enthalpy of formation is measured in units of energy per amount of substance. However, most are defined in kilojoules per mole, but can also be measured in calories per mole, or joules per mole, or kilocalories per gram. Any combination of these units conforming to the energy per mass or amount guidelines is actually representable. The formation reaction is a constant pressure and constant temperature process. So since the pressure of the standard formation reaction is fixed at 1 atm, then the standard formation enthalpy or reaction heat is a function of temperature. Standard enthalpy of formation are used in thermochemistry to find the standard enthalpy change of any reaction. This is done by subtracting the sum of the standard enthalpy of formation of the reactants, that is, each being multiplied by its respective stoichiometric coefficient, from the sum of the standard enthalpies of formation of the product. That is to say that each also multiplied by its respective stoichiometric coefficient. And this is actually shown as in this particular equation. So we have standard enthalpy of formation given as the stoichiometric coefficient multiplied by the standard enthalpy. And remember, this means summation of. So we look at the product minus that of the reactant. So if the standard enthalpy of the product is less than the standard enthalpy of the reactant, the standard enthalpy of the reaction will be negative. This implies that the reaction is exothermic. The converse is also true. That is to say that the standard enthalpy of reaction will be positive for an endothermic reaction. So we calculate the standard enthalpy of the product, calculate that of the reactant, then we subtract the reactant from the product. And you can see from this example, if you are interested in calculating, or if you want to calculate the standard enthalpy or standard enthalpy of formation of this reaction, we first calculate the standard enthalpy of the product here, calculate that of the reactant, then we subtract the reactant from the product. When the reaction is reversed, the magnitude of the change or the enthalpy stays the same, but the sign changes. When the balance equation for reaction is multiplied, so I made mention of this earlier. If we reverse the reaction, the magnitude does not change. However, if we divide the equation, then the magnitude will change. If we reverse it, what happens is the sign only changes, but the magnitude does not change. When the balance equation for the reaction is multiplied by an integer, the corresponding value of H, the enthalpy, must be multiplied by that integer as well. The change in enthalpy for the reaction can be calculated from the enthalpies of formation of the reactant and then the product. Elements in their standard states are not included in the enthalpy calculation for the reaction, since the enthalpy of an element in its standard state is 0, which we made mention earlier on. So for example, calculate the standard enthalpy of formation for the synthesis of lime, CaO from limestone, CuCO3, which is an important step in the manufacturing of what? Cement. So we are given the standard enthalpy of formations of the product and the reactant. So all we have to do is to substitute them into the formula, and then we calculate our standard enthalpy of formation. So kindly input those values and let's get the correct answer. So by doing that, you realize that you substitute them into their respective equations and you have an enthalpy of formation of 178.3 kilojoule per mole. In this session review, please do find time to solve these questions, which will give you an upper hand or familiarize yourself with the equations and how to do the calculations of standard enthalpy of formation. Thank you, and I hope to see you.